Now I am going to tell you electric field due to electric dipole. Electric field due to electric dipole. Now what is electric dipole? If I give you one simple example, that is of atom. In atom, what is there? One positively charged nucleus is here at the center, and electrons are moving around this positively charged nucleus, and this distance between this negative charge and this positive charge is very small. So this atom can be called as dipole. It is electric dipole. So what is the definition of dipole? And one thing, this electron and this proton, suppose this is hydrogen atom, so one proton is in nucleus and one electron is in orbit. This electron and this proton has equal charge, one is positive and one is negative. So what is electric dipole? If two equal and opposite charges, suppose this is minus q, then it should be plus q, are separated by a small distance, then the system together is called as dipole. I am writing the distance between two charges as 2L. Why 2L? We will see further. That is for convenience of calculation, nothing else. So here I define one another thing, that is dipole moment. What is dipole moment? Dipole moment is just moment of force or torque was one force into distance between the two forces. So here dipole moment is equal to P is equal to Q into 2L, that is any one charge into distance between them. This is magnitude. What is direction? Dipole moment directs negative to positive charge. Dipole moment directs negative to positive charge. So direction of dipole moment will be like this. This is P. This is the direction of dipole moment. I think this is clear. If this is clear, we move forward. What? First case, that is electric field at a point or at an axial point of dipole. What is axial point? Suppose this is minus q charge and this is separated by a distance 2L. I am giving the name A, B, this is O. So this length is L, this length is also L, and we have to find out the electric field at a point P, at a point P, which is at a distance r from the center of the dipole, that is OP is equal to r. Remember, this is small p vector, that is dipole moment, and this is capital P, this is just a point. Now we have to find out the electric field at point P. So first we will find out the electric field due to minus q, then we will find out the electric field due to plus q, then just vector addition and you will get the total electric field at point P due to the whole dipole. So what will be E minus q first, that is electric field at point P due to minus q charge. I am giving the vector sign. First tell me what is the magnitude. Magnitude is simple, 1 by 4 pi epsilon 0, or you can also write it like small k, 1 by 4 pi epsilon 0 q by, what is the distance, AP, that is AP square. What is the direction? It is negative charge, so the direction of electric field will be towards negative charge. This is E minus q. So I am writing here along PA, this side. So what is AP? Here you see AP is equal to AO plus OP. This full distance is equal to AO plus OP. What is AO? AO is equal to L and OP is equal to R. So AP will be is equal to 1 by 4 pi epsilon 0 q by R plus L whole square. This is also along AP. Now what is E plus Q? E plus Q will be, the distance will be BP, so it will be 1 by 4 pi epsilon 0. I told you that only take magnitude of charge, so there will be no negative or positive, it will be just BP square. So what is BP square? This BP square will be equal to 1 q by BP is equal to this R minus L, because BP is equal to OP minus OB. OB is equal to L, so BP is equal to R minus L. This is R minus L whole square. What will be direction? Direction will be along BP. Why BP? Because this is positive charge and electric field is directed outward along BP. So you see here why I have taken here 2L to put this one L and this one L, two part. If I take L, then it will be L by 2, L by 2. So that will be a little inconvenient, so I took it this way. Now what is total electric field? E. So the resultant electric field at P, we left here that E minus Q, which is electric field intensity at point P due to minus Q charge, and E plus Q is equal to electric field at P due to plus Q charge. So what will be resultant electric field? As I told earlier, that the resultant electric field will be just the vector sum of E plus Q and E minus Q. Here I forgot to show the direction of E plus Q and E minus Q. This is E minus Q and this is E plus Q. Now you see, if net electric field or resultant electric field at P is capital E vector, then E vector is equal to just the vector sum of E plus Q and E minus Q. Now I will separately discuss about the direction and magnitude of this net electric field. First let us take magnitude. Magnitude. What will be the magnitude? Magnitude will be equal to, as we know from our vector knowledge, that magnitude of E vector is E only. It will be is equal to E plus Q square plus E minus Q square plus 2E plus Q E minus Q cos theta. Now here what is theta? Theta is angle between E plus Q and E minus Q. What is angle? Theta. You see, they are opposite to each other, so the angle will be equal to 180 degree. So here if I write, so E will be E plus Q square plus E minus Q square plus 2E plus Q E minus Q cos 180 degree. What is the value of cos 180 degree? It is minus 1. So the resultant value will be equal to E plus Q plus E minus Q minus 2E plus Q E minus Q. So this is the formula of A minus B whole square. So it will be equal to root over E plus Q minus E minus Q its whole square, which equals E plus Q minus E minus Q. Now you can say that I can also write E minus Q minus E plus Q. Why did I write E plus Q minus E minus Q? Because here you see in the denominator it is R minus L whole square, magnitude of E plus Q. In the denominator it is lower compared to E minus Q, because in E minus Q it is R plus L whole square, which is greater. So as it is in denominator it is greater. That means the total value of E minus Q will be less. So I am writing E plus Q minus E minus Q, that is greater value subtracted from lower value. That is why E plus Q minus E minus Q. So now we have to substitute the value of E plus Q and E minus Q here. So what will be the final result? It will be magnitude of E, magnitude E will be equal to E plus Q minus E minus Q. That is, if I take 1 by or Q by 4 pi epsilon 0 common from these two, then I will get 1 by this one first, that is 1 by R minus L whole square minus 1 by R plus L whole square. So I am writing it again, 1 by R minus L whole square minus 1 by R plus L whole square. So what will be LCM? It will be Q by 4 pi epsilon 0 R minus L whole square R plus L whole square. So here it will be R plus L whole square, here it will be minus R minus L whole square. Now I am just doing my calculation. R minus L into R plus L, it is R square minus L square and this whole square. So A plus B whole square minus A minus B whole square. What is the formula? The formula is 4AB, that is here it will be 4RL. Now I am writing it like this, 2. I am taking 2 out here, 2 into Q into 2L. So that is 4L is here, 2 and 2L here. I am giving it a bracket into R by 4 pi epsilon 0 R square minus L square whole square. Now why I am writing like this? Because from our previous knowledge we know this, that q into 2l equal to, that is charge into the distance of separation, is equal to dipole moment. So it will be 2 times small p, that is dipole moment, into r by 4 pi epsilon 0 r square minus l square, its whole square. So this is the general expression for electric field at any axial point or at end-on position. Now I will give you a special case. What will be the special case? The special case will be, I am coming back here. If r is very greater than l, which is very common in many cases, as I have told earlier, that dipole moment, length of dipole, it is called this 2l is called length of 2l, that is distance between minus q and plus q, it is called length of dipole. That length of dipole in many cases is very less than capital R, small r, that is OP. So if I put this approximation here, what will you have? R square minus L square. This R square minus L square will be approximated to R square. So what will be the final result? That E will be is equal to 2 PR by 4 pi epsilon 0 r to the power 4. So this r will become r cube 4 pi epsilon 0 r cube. So you see, just 1 by 4 pi epsilon 0 into 2p by r cube. This is the result. 1 by 4 pi epsilon 0 2p by r cube. That is magnitude. This is magnitude. Now tell me, what will be the direction? What will be the direction of magnetic electric field? What will be the direction? You see, as I have done earlier, that magnitude E is equal to E plus Q minus E minus Q. Why we did that? Because E plus Q is greater than E minus Q. Now the direction will be obviously in the direction of E plus Q because it is higher. So direction of electric field will be along this direction, that is OP, right hand side, left to right. And another thing, you must remember that dipole moment. What is the direction of dipole moment? Direction of dipole moment is always from negative to positive. From negative to positive. So that is direction of dipole moment here is along this direction. So this is dipole moment, direction of dipole moment. And you see again that net electric field will have the direction of left to right, and dipole moment is also along left to right. So we can say that net electric field at point P must be in the same direction as that of dipole moment. So in vector form we can write it like 1 by 4 pi epsilon 0 to P vector by R cube. So this is our final result.